All right, warriors, this is algebra, and we are in Chapter 7, Lesson 2, and we're going to do Example 2. I know you might be confused because this picture on the board kind of looks like it's biology time, right? Now, if you haven't done heredity yet and Punnett squares yet in biology, you might recall doing it in Science 7. If you haven't done that, gotten to that part yet in Life Science 7, well, you're going to be ahead when you get there. Okay, so I'm going to show you using the Punnett square. Then we're going to transfer this skill over to algebra and multiplying polynomials. All right, so there was this guy named Gregor Mendel, and I don't know, for some reason he really liked peas, and he studied pea plants, and he studied the various characteristics of peas, and he learned from all of his studies information about genetics. And so let's say we have a pea plant, and it is a capital G, lowercase y pea plant. And he crosses that with another capital G, lowercase y pea plant. All right, so what we do is we take the letter from here and bring that down, and we take the letter from here and bring it across, and we get capital G, capital G. And then we do the same thing here. We bring down the Y, we bring across the G, and this one is capital G, Y. And for this one, we bring down the G, we bring across the Y, and we get capital G, Y. And then for the last one, bring down the Y, bring across the Y, and we got two lowercase y's. And so what ended up happening is we end up with one pea plant that is only going to be green, and it will only give offspring. It will only have green offsprings. We have another one that was GY, and another one that was GY, and these ones look green, but they could reproduce yellow offsprings. And then finally we had the YY, and those are just yellow peas. All right, and those were the recessive ones, and they can only give offspring to, well, all of their offspring would have a lowercase y in them. Your biology teacher is going to explain this so much better. Let's take a look at these dogs, okay? So the dogs could have brown patches, well, I guess black patches or red patches. Okay, so black patches or red patches. Now, both of these dogs have black patches, but their genetics show big B, little r. Big B, little r. All right, so we take one from here, and we take one from here, and we get big B, big B. We take one from here, and one from here, and this one's going to be big B, little r. Okay, we take one from here and one from here. We get big B, little r. And finally, we get one from here, and that's little r, little r. And that one was the only one that was going to have red patches. All the other ones were going to have black patches. That's how they would look, even though they're genetically different. We would have one double big B, we'd have two BR, BR, and we'd have one RR. All right, same thing. Oh, now sometimes the characteristics would mix together. Okay, so look at this. We've got a dog with black and white patches. We've got another dog with black and white patches. Okay, so we've got big B, big W, big B, big W. Now, what happens when these dogs reproduce? We're gonna bring one big B over, and we get big B, and that dog will be black. Okay, so we'd have one double B. On this one, we'd have a capital W and a capital B. So that gives us BW, and it turns out those will mix together and that dog will be gray. All right, what about this square? We take the B from here, we take the W from here, and we get another big B, big W. So we're going to have another dog that's gray. And finally, for this last one, we take the W from here, the W from here, and we get WW, and that dog will be white. All right, now, what does this have to do with math? Well, we're going to do the same type of thing using binomials. All right, so we're going to take the two binomials and we're going to set them up using the square. Okay, we're going to use the boxes. So let's do this. Let's take this one right here. I'm going to change color so it's a little easier to see. Okay, let's take this one right here and we're going to rewrite that. I'm going to write that as 2x. I'm going to put the first term in the first box. And I'm going to put the second term in the second box. So 2x minus 3. And I'm going to take this binomial, and I'm going to put the first term in the first box, and the second term in the second box. And now I'm going to multiply everything together. Oh, I should not put an x for multiply. Okay, just multiply. I'll just write multiply. I'm not going to put x because that's going to confuse us with the x's that are in the actual problem. All right, so we're going to say 2x times x. 2x times x, 2x squared. All right, now let's take the negative 3 times the x. So negative 3 times x would be negative 3x. All right, now for this square, we're going to take this one and this one. Okay, so we're going to say 2x and positive 5. Let's multiply that together. 2x times positive 5 times positive 5. So that's going to be 10x. And for this last one, we're going to take this one and this one. Okay, so I'm going to bring this one down, and I'm going to bring this one across. Multiply negative 3 times positive 5. That's negative 15. Now, we can't leave it in the boxes, but we're going to just take each box and we're going to write them out. So we're going to have, let me write them over here. We have 2x squared minus 3x plus 10x. I know it's plus because that one's positive. And then minus 15. And the only other thing I need to do is combine like terms. All right, so I don't have anything to combine the 2x squared with, but I can combine this with this, and that's going to give me positive 7x, and then minus 15. Okay? Now, could we have just done the distributive property with that? Could we have just gone like this and gone like that? Yes, we could. But some of us are going to like this box better, and I want you to try a few with the box because later this is going to be really helpful to us. All right, what are we doing next? We're going to do, looks like we're going to do more of the same. Okay, It says multiplying volume. Oh, this is still example 1. Wait, didn't I do example? Oh, I know what I'm doing. So with example 1, we did it with the distributive property. What I want to do is redo those 2 problems using the box. Okay, now, I don't think I'm going to have time to finish these on this video, so I'm going to do this with the next video.